In the last lesson, Python learned to remember individual values, but real problems rarely manage just one thing. They manage groups of things, a sequence of tasks, a profile full of details, a collection of tags, or a schedule that should not change. Today, we're taking one messy study plan and turn it into a smart study dashboard. Along the way, strings, lists, dictionaries, sets, and tuples will each solve a different problem. By the end, you will not only recognize this structure, you will know why you would choose one over another. Let's just meet the messy data before we organize it. Imagine opening your study tracker. The course name is inconsistent. Your tasks are scattered across separate variables. Study minutes have numbers, but no useful labels. The same topic appears twice, and your fixed weekly schedule can be changed. Python can store all of this, but storing data is not the same as organizing it well. The real question is, what shape should each piece of data take? To answer that, we need a simple mental model. Think of this structure as containers on a study desk. A string is one written message. A list is a numbered checklist where order matters. A dictionary is a labeled cabinet. You do not ask for drawer number 2. You ask for the drawer named practice. A set is a guest list that keeps only one copy of each name, and a tuple is a fixed schedule, ordered but intentionally locked. The important idea is this: choose a structure by the behavior you need, not simply by how the data looks. We will start with the simplest container, text. Our dashboard needs a course name, so we begin with a string. Python accepts both single and double quotes, but the choice matters when the text contains an apostrophe. Here, double quotes safely surrounded Python developers' path without ending the string earlier. For the text that naturally spans over several lines, like a weekly note, triple quotes keep the format readable. Quotes are not decoration. They are the boundaries that tell Python exactly where the text begins and ends. Storing text is useful. Cleaning it is where string become powerful. Real data rarely arrives perfectly formatted. A course name might be typed in capital letters, or an old message might mention the wrong subject. Strings methods lets us transform that text. The lower method creates a lowercase version, replace search for one piece of text, and substitutes another. Here is where beginners often get confused. Strings do not change themselves. The method returns a new string, so we assign that result back to the variable when we want to keep it. The output is now consistent and ready for a dashboard. One course name fits in a string, but several other tasks need something different. We could create task 1, task 2, and task 3 as separate variables. That works until the plan grows. A list gives the related task one home. The square brackets define the list. Commas separate its values, and the original order is preserved. That order matters because watching the lesson should happen before writing notes, and notes should happen before practice. Once the tasks are ordered, Python needs a way to locate each one. Python calls an item's position its index, and indexing starts at 0. A useful way to think about it is distance. The first task is 0 steps away from the beginning, so its index is 0. Negative indexes count backward. Minus 1 means the final item, no matter how long the list becomes. So 0 gives us watch the lesson, while minus 1 gives us practice the code. An index selects one item, a slice selects a section. Slicing is like selecting a section of a playlist. The first number says where to begin, the second number says where to stop, but that stopping position is not included, and the optimal third number controls the step. 0 to 2 returns the fast task. 1 followed by a colon means start at index 1 and continue to the end. 2 colons followed by 2 means take every second item. Do not try to memorize every variation at once. Read the pattern as start, stop, step, and test the result. Lists answer. What is at this position? Dictionaries answer a more human question. Suppose the dashboard stores 20, 15, and 30 in a list. Which number belongs to practice? You would have to remember its position. A dictionary removes that casing. Each key is a meaningful label. Each value is the data connected to it. Video points to 20, notes point to 15, and practice points to 30. The code now reads like a question. We would naturally ask, how many minutes are assigned to practice? And once the level exists, working with the data becomes direct. A dictionary gives us three common moves. First, use a key to read its value. Second, assign a value to a new key to create an entry. Third, assign a new value to an existing key to update it. Notice that adding and updating use the same syntax. Python checks either the key already exists. If it does, the old value is replaced. Dictionaries can't keep two separate entries with the same key. The keys and values method then lets us inspect the two sides of a dictionary separately. Our minutes need labels. Our topic history has a different problem, duplicates. The student studied strings twice, so the original list contains strings twice. But if the dashboard only needs a catalog of cover topics, repetition adds no value. Converting the list to a set keeps one copy of every topic. Think of a set as a guest list. A name is either present or absent. There is no second identical guest. That uniqueness comes with a trade-off. Sets are not designed around position, so we can't reliably ask for item 0. We can sort it here only to display the values in a predictable order. Use a list when order matters. Use a set when uniqueness matters. There is one final container designed for data those order matters, but those values should stay fixed. Our weekly studies slots are ordered, just like task, but unlike task, this schedule is meant to be fixed. A tuple communicates that intention. Tuples use round bracket and supporting indexing. So index 1 returns Wednesday at 7 p.m., but their values are immutable. After the tuple is created, an individual item cannot be replaced. A list says this sequence may change. A tuple says this sequence should remain stable. Now let us combine all five structures in one working program. Let us build the dashboard from a blank file. I will name it episode 2 dashboard.py. First, the course name is one piece of text, so it becomes a string. The next task belongs in a list because their order matters. The study minutes goes into dictionary because labels such as video and practice are more useful than numeric position. For topics, I will deliberately writing strings twice before converting the values to a set. That gives us visible proof that duplicates disappear. Finally, the weekly schedule becomes a tuple because it's an order plan. We intend to keep it fixed. Now look at the print statements. Each one demonstrates different kinds of access. The complete string, The first list item are dictionary values selected by a key, a shorted view of a set, and the first tuple item. Let us run the program. The dashboard reports the course. The first task 20 practice minutes, 3 unique topics, and Monday as the next session. 5 variables, but 5 are very different jobs. Area structures was chosen intentionally. The dashboard works, now the viewer has to make it their own. Before we finish, make the decision yourself. One piece of biography text is a string. Order tasks belongs in a list. Label profile details fit in a dictionary. Unique tag belong in a set. And a fixed coordinates fit a tuple. Now upgrade the dashboard. Add one more task using append. Change the practice value in the minutes dictionary. Then try adding a topic that already exists and observe what the set does. If one structure still feels confusing, write a tiny example and print it. Confidence in programming comes from seeing the behavior, not from memorizing definitions. Today we gave data the right shape. In the next stage, we will turn stored data into program behavior. Build a new challenge before moving it. Because the moment you change the project, the code stops being my example and start becoming yours. Invite the viewers to continue the Python series.